So the first part of 3.4 was learning to work with radicals. And now here we're going to continue with that. We've got operations with radicals. Now, they did in the previous section or first part of this we did multiplication and addition, subtraction. We did not do anything where radical looked like it was underneath dividing. So again, we don't want to go to decimals. What we're going to do with these is we're going to simplify these instead of evaluating by decimal, right? So again, we're not reaching for the calculator. We're not going to decimal. I need you to remember these words here. Rationalize is a new word. When we rationalize something in math, it means to get rid of the radical. We're getting rid of the radical. We're going to use that word in future math as well. Okay, so we'll use this word. And this is going to be something, I literally had this today when I was teaching my grade 12 class, and they said, should we do that thing with that denominator? Yes, you should rationalize, right? So we're going to expect you to be able to do this from now on. All right, so rationalize the denominator. I want you to know that word. So rationalize the denominator. What does that mean? It means get rid of the radical. What do I need you to remember? I need you to remember this property about radicals. A root 3 with a root 3 equals root 9. Make sense? Okay. But root 9, can I go a little faster? Instead of writing root 9, can I skip and go to 3? Okay, so I want you to try. Last lesson I was like, try to get there, and I want you to try again. So root 5 and root 5, yes, it's root 25, but try to go a little faster. So this is one time where I'm encouraging you to try to skip to that, to the 5. Okay? So that's the goal. So in your head, you're going root 25, which is just 5. So try your best. If you write root 25 and then go there, that's okay. But if you can miss this step, it'll save you a bit of time. And you'll see why when we're doing the next bit. Okay. Now, other thing I need you to remember, so recalling this, that we know how to do this. For difference of squares, there's no middle term, right? So difference of square, that means there's no middle term. So if I have A and B, and I'm going to tell you these things, and then we're going to see where I'm going to use it in the questions below. So A plus B and A minus B, right, like that. Difference of squares, the reason why this was special was because they're the same but opposite sign. And the reason why it's special is because I end up with A squared, missing middle term, B squared. That's what makes this so special. Does that make sense? Right, so this scenario here where they're exactly the same but opposite signs, that's what made it special because the middle term goes away. Okay, so now, knowing that, knowing these things to remember, I want you to rationalize the denominator. The question may say just simplify. It might just say simplify instead of rationalize. Okay, so over here, if I have this scenario, again, don't reach for your calculator. You're going to say, I don't want this root on the bottom. That's what rationalizing means, right? So this means no in denominator. Okay, I don't want that root in the denominator anymore. So what am I going to do? I'm going to multiply the top and the bottom by root 5. We're going to multiply the top and the bottom by root 5. So over here, you're going to do root 5 and root 5. So whatever you do to the top and the bottom, whatever you do to the top, you do to the bottom. Whatever you do to the bottom, you do to the top. Now remember, this only works for a fraction. So why am I doing this? So go back one more time. You're like, wait, why didn't we do this yesterday? This is the only time we're doing a division, right? So all of the work that we did here, do you see any roots in the denominator? No roots in the denominator. So this only happens when you have a root in the denominator. So what we're going to do is we don't want the root in the denominator, so we're going to rationalize it away, right? So we're going to get rid of that root. Why am I multiplying it by itself? Because look, when you multiply root 5 times root 5, it becomes root 25. Can we skip that step and go 5? Now what's my denominator? 5. What was it before? Root 5. But now it's 5. Did I rationalize it? Yes. This is called rationalize, where I got rid of the root. What happens to the top, though? What happens to the numerator? 2 times root 5, whole number times whole number, root times root. So it's the whole number is 1, so it'll just be 2, and root times the root, root 5. People go, can I cancel the 5s? No. Root 5, that's root 5. That's like a bracket, right? So that's saying that's a root 5, which is a decimal place. It's not the same thing as 5. No canceling. So this is it. You stop. It's beautiful. That is gorgeous. That is way prettier than this. This you're supposed to look at and go, ugh, yuck, there's a root on the bottom. I should rationalize that. So when you look at this for future ones, right, and that's what happened in my other class this morning, they looked at it and went, ugh, there's a root on the bottom. Do you want us to rationalize it? And I said, yes, absolutely. That's what we're going to do with our grade 11s today as well. Okay? So as soon as you see a root in the denominator, you go, ugh, that looks like it could be rationalized away. So you go, ooh, no, no, no roots in the denominator. So yuck, yuck, yuck. Okay? How do we get rid of that root? We multiply by itself. Multiply by itself, because then root 3 times root 3 becomes, gloriously, 3. Does that make sense? So that's why I needed you to remember this. And that's why you don't have to write root 9 and then 3, or root 25 and then 5. It just makes it easier if you go straight to the 3. Okay, it saves you a step. So that's when I'm encouraging you to skip that step. Okay, so look. Ew, ew, ew. No, no roots in the bottom. So when you see a root in the denominator, you're supposed to say, oh, no, 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 no. That looks messy. I don't like it. Let's get rid of it. How do you get rid of it? You multiply by itself. And then you do whatever you do to the bottom, you do to the top. Whatever you do to the denominator, you do to the numerator. Whatever you do to the denominator, you do to the numerator. This only works for fractions. This only works in the fraction scenario. Okay, so see how it's only fractions that we do this for, because we're never allowed to have a root in the denominator. It's a form thing. It's basically like reducing your fractions. You would reduce your fractions. This, to me, looks unreduced. Like, ugh, that's not right. It's just wrong form. The number's the same, right? The answer's the same. So if you were to take out your calculator and you go, but wait, I haven't done anything. I've just changed form. So just like when you reduce, if I did 4 divided by 8, that's the same thing as 1 divided by 2, right? So if I said 4 over 8, is that the same thing as 1/2? Yeah. All I'm doing is changing the form, right? So 4 over 8, there's still 0.5. So if I'm changing the form, 2 divided by square root of 5 is 0.8944, blah, 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 blah. This is 2 times root 5 equals, and then I divided that by 5. I get the same number. Like, I'm not calculating, I'm just changing it so it's neater. This, to me, looks not neat. That's like, ooh, that's not neat. So I'm just changing the form. So whatever you do to the top, you do to the bottom. Whatever you do to the bottom, you do to the top. Does that make sense? So we're just changing form. Just like any fraction, whatever you do to the denominator, you can do to the numerator, and you're okay. You're just changing it. So when I see that, I go, ooh, no, 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 no. No radicals on the bottom. No radicals on the bottom. No, no, no. No radicals on the bottom. What do? You multiply by whatever it is, so that what's the denominator now? Yes, 3. Okay? Here. Now we know how to multiply from yesterday. Whole number times whole number. There's an invisible 1. Right? So that would be 3. Root times root. So that gets me root 6. Does that make sense? Okay. Can I reduce the 6 anymore? What do I mean by reduce? It means simplify. Can I simplify the 6 anymore? No. I'm looking for perfect squares, right? My perfect squares are, you remember them? You got 4, 2 times 2, 9, 16, 25, etc. Right? So we're looking for perfect squares. Nothing, so we stop there. Can I reduce the 3 and the 3? Yes. You are allowed to reduce a whole number with a whole number or a root with a root. So see here? See the contrast? I cannot reduce a whole number with a root. Those are different numbers. That's a decimal something something. That's a whole number. I am, see I'm trying to contrast it? I am allowed to reduce a whole number with a whole number though, because that's just a fraction. So think of that as a fraction, 3 over 3. Can I reduce that? Yeah, right? You reduce the 3 over 3. That reduces to be 1. So then you rewrite it as root 6. So that is simplified as possible. Okay, try it again. Okay, let's try that again. So we have root 12. I would just multiply by root 12. I know that root 12 is actually, what's it called? Reducible, simplified, something I can simplify. So I'm going to show you both ways. So I left a bit of room here on the side. So I'll do an or here. But I think my instinct would be just to multiply this by root 12 on the top and the bottom. Okay, and then there's actually 3 different ways we can do it. I'll show you. Okay, so I wouldn't simplify the 12 and do 4 times 3. I would just go ahead and multiply by the 12. I find that easier. Okay, I'll show you, there's actually 3 different ways. So I'll show you maybe 2. I don't know if I want to show you 3 different ways, but I would multiply the top and the bottom by the 12. Right, I think that's easier. Then I would get in the denominator, root 12 times root 12 is 12. Okay, all right. 4 root 6 times root 12. Whole number times whole number, so 4. Root 6 times root 12 is root 72 times 12. Can I reduce anything? Yeah, what can I reduce? The 72. I can reduce the 72. Also, what else can I do? What else can I do? Yeah, the 4 and the 12. We just talked about that. So whole number with whole number, I'm allowed to reduce that. So the 4 into the 12, divide the top and the bottom by 4. Does that make sense? It's just a regular old, what's it called, fraction question, which we love. Yes, 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 we love fractions. So divide the top and the bottom by 4, so I'm going to get, and I'll do the 72. So if I divide the top by 4, it's just a 1, right? And then I divide the bottom by 4, it becomes a 1/3. So think of that as a separate question. Right? So think of that, the whole numbers as a separate question. The 72, I'm going to simplify that one. That is actually 36 times 2. Right? We did that in the previous lesson. Root 36 comes out perfectly as 6. 6 times 1 is just 6. Leave the leftover 2 inside. Okay? And then on the bottom, I have a 3. There you go. Beautiful, isn't it? Is it, though? It's beautiful because it doesn't have a... What else can I do? Yeah, one more time. Look at your answer one more time and go, oh my gosh, it's a never-ending question. That's why a lot of these are like you don't know where to stop. So you're going to go 6 and the 2, 3. That becomes, so divide the top and the bottom by 3. Right? You don't have to show this part on the side, but I'm showing you my thinking. Right? My thinking was divide top and bottom. And then I've got 2, root 2. Are you going to leave it like that? No. Right? So you don't have to show this, but I don't want this on the bottom denominator, okay? So I don't want to see that, please. So you can go straight to root 2. Don't leave it over a 1. It's just like when we did fractions. You wouldn't leave it over a 1. Okay, so same fraction habit from before. Okay. Or, so there's, yes? The square root of 36. So how did we get from here to here? The square root of 36, I take out the root 36. I make it 6 times the 1 in front, so 6, and I leave the remainder inside. Does that make sense? So you always take out as much of the perfect square as I can. So square root of 36 is exactly 6, so that goes here. And the remainder 2 stays inside of the root symbol. All right, so that's one way. That's beautiful, perfectly good. Also, so there's two other ways. I can't fit two other ways. I'm going to do one other way. Okay, so another way, so or is, I'm going to rewrite the question. So my question is 4 root 6 over root 12. Now, what you could have done is, remember here I said, you cannot cancel the 5s even though you want to, because one is a root and one is a whole number. Here you can cancel a whole number with a whole number, yes. Are you allowed to cancel a root with a root, though? You are. You're allowed to cancel it because like they're in the same bracket. They're both in that root bracket, like a special symbol. So you are actually allowed to divide. You're allowed to cancel this with this because they're both in that root symbol. You can't cancel if they're different. If one's in a root and one is not, no. If they're both not, you can do it. But if they're both in the root, you are actually allowed to cancel that. And you're going to go, so the 4 stays here, okay? And what do I mean by cancel? You're dividing the inside by 6. So that's root 1. Do I have to write root 1? No, you can if you want. Like if you're like, you know what, it helps me write it, but you don't have to write that. And then here, that would be root 2. So no, you don't have to write the root 1. You can if you want for one step and then get rid of it the next step. But that becomes root 2 on the bottom. Is that done? No, because what's U about it? The root on the bottom, right? And so what do I do to get rid of the root on the bottom? What do I do? Which is that? What's that going to be doing? What are we doing? Yep. Yes, by itself. Top and bottom by itself. Okay? So you go, ugh, that's not done. Then I'm going to go ahead and I'm going to get 4 root 2, whole number times whole number, root times root. Root times root just gets me a 2. Am I done? You're going to hate me asking this question. No, because those guys can't. Whole number can reduce with the whole number. And again, you're just dividing the top and the bottom by 2. If you cancel, that's okay. It means the same thing, but I'm showing you my thinking, right? So that cancels will be 2, right? So whichever way you do it, some people call it canceling 2 root 2. Oh, look at that. They're the same. So there's going to be more than one approach. There's one other one where you reduce the 12 first and then you rationalize. That works as well. Okay, so rationalizing is something you have to get used to doing. It'll come back like forever now. Just in bits and pieces. We just use this every once in a while. Okay, ready? Let's try it again. Just going to give you longer questions. Okay, so here we've got 4 root 18, 3 root 27. I do not like the root 27 on the bottom. Do I have a problem with the 3? The 3? No, he's fine. This one's fine. The 3 is fine. I don't mind the 3 at all. Okay, the 3 is fine. Okay, good, good, good. Don't rationalize the 3. There's nothing to rationalize there. Okay, so leave the 3 as is, okay? But the 27 needs to be rationalized. So what you're going to rationalize is 27, not the 3. So I'm going to write that down. So not 3 root 27, okay? Also, do you want to reduce it first, though?
Good afternoon, teachers.
Do you want to reduce it? Because multiply by 27, it's going to get 18 times 27. You go, oh, Ms. Zen, really? You want 18 times 27? Nah, I kind of wanted you to see that you could reduce it, like I just showed you here. First, it's not wrong, but then you're going to deal with big numbers, and then you have to reduce that. So can we go back and go, let's try that a better way, right? So it's not wrong if you don't reduce it, but it's a little nicer, right? Because 18 times 27, then you got to do a root. Oh, it's pretty big. It's not going to be wrong, but look, 486. And then I'm going to go, okay, so maybe a 4. No. And then you have to go through and find it. So do you see where that is useful, doing this? right? So doing that is useful. So let's start the question again. But I would not multiply by the 3, okay? So then take that away, and I'm going to go, you know what? It is nicer if I do that. So I did that on purpose because everyone's like, yeah, rationalize. And you start to not look at the question. I want you to look at the question first, okay? Look at the question first. So look. See your eyes. First. Okay? Just to see if you can reduce it first. Just makes your life a lot easier. So then if I look first and I can say, can I reduce 18 and 27? Yes, I can divide the top and the bottom by 9. Feels good. Biggest is 9. So divide the inside, just the inside, by 9. Then I'm going to rewrite it. Okay, so I'll leave the negative 4 and the 3 out here. And this now becomes root 2. Ah, much nicer. And root 3, much smaller. Right? So if you just look at the question and you're only doing it, you have to stop, and that's why I want you to try it, because, boy, that number's way bigger. Okay, so see if you can reduce it first. Then I'm going to multiply it not by what? Not 3 root 3. I'm only trying to rationalize the 3 root 3, not the whole thing. I just want you to do the 3. Okay, just the root shouldn't be there. Don't do times 3. That's not rationalizing. That's this. Okay? So you're going to rationalize it by multiplying top and bottom by root 3, just the root 3. Okay? Not 3 root 3. The whole number 3 is not doing anything wrong. The root shouldn't be down there. So then multiply that. Okay, let's go. And we've got negative 4, whole number times whole number, root times root, whole number times whole number, 3. Root times root is, root 3 times root 3 is root 9, but if you can skip it, you can write it. Like you can write root 9, do another step, but if you can skip it, there. Okay, if you can, just write root 9 is root 3. Keep going. Never-ending questions. 6 over 3 times 3 is 9. Can I reduce that anymore? Whole number with whole number? No, root has not done. Stop. So again, a lot of these radical questions, you have to know when to stop. Yeah.
The first step, when you canceled out the root 9,
Yeah.
can you write it in the first step, like root 9 times root 2, and root 9 times root 3?
Yes, yeah, so you can do root 9, yes. So then the question is, can you write it out? So you got the root 9, root 2 over root 9 and then root 3 like that. And then you've got the negative 4 and the 3 like that. So yeah, you can do it that way and cancel it that way. Yep, you can factor and then cancel, yes. Right, and that's using the property we had yesterday, right, that we can break it apart. Right, and that goes for any, so even if it was a 5, so it doesn't have to be a perfect root. If it was like this, you can do that. Does that make sense? Yeah, perfect. Okay, good? Okay, so then let's do one more here, and we're going to rationalize this one. So we want to rationalize this, and we multiply the top and the bottom by how is this one different than these ones we just did? How did I make the denominator different? How is this denominator different than all those denominators? Yeah. There's 2 terms. Yes. Okay? So there's 2 terms here versus, so it's a binomial. So this one here, this is different. I'm just going to put a line here because it's a binomial. Okay? So this one's different because this is a binomial. Binomial. Okay, so this one's a bit of a thinking question, right? So we give you this one now. It's a little bit of a challenge question, but I'm going to show you. Okay, how would you rationalize this? And what I want you to do is go back to this box here and this idea of a difference of squares. You're going to multiply it by the difference here. And it's called not a difference of squares because it's not variables. You're going to multiply by the opposite. So look, 2 root 3, and instead of a minus, we're going to go plus 5. How does that accomplish anything? And we're going to do the same thing to the bottom as we are to the top. How does that fix anything? You might go, how is that going to get rid of the root? Now watch. See how they're opposites? That makes them difference of squares. Then you do first times first. Can you do root 2 root 3, 2 root 3 times 2 root 3 for me? We practiced this yesterday with the distributive, right? So yesterday we were showing it works just like FOIL, right? So here, this is a difference of squares. First times first would get me 4, 2 times 2. What's root 3 times root 3? Root 3 times root 3? 3. We're trying to skip to 3 instead of the 9. The middle terms cancel away. It's a difference of squares. Then I go minus 25. Does that make sense? Because it's a different, and how did you make it a difference of squares? You chose it. So see here, I was multiplying by the root. Here I'm going to multiply. This is called the conjugate. Conjugate when it's the opposite sign. When these guys are opposite signs. When you do the difference of squares. When you make the difference of squares, that's to make the difference of squares. Then you multiply what's called the conjugate. Now, what do I do? So did I get rid of the root on the bottom? Did I succeed in making this not right? I can't multiply by just root 3. Some people go, can't I multiply by root 3? What happens if you multiply by root 3? I always get that question. So look, so if I go 2 root 3 minus 5, what happens if I multiply by root 3? That gets rid of this one, but look, I get a 5 root 3 there. Whole number times whole number, whole. Then you just go, but then now this one has a root 3. So there's no way you can get over root 3 if it's only on one term by multiplying by root 3, because look, I get 5 root 3 here. It gets rid of this one, it becomes root 9, but not this one. Does that make sense? Okay, so you can't do it by multiplying by one term. You have to do difference of squares. So that's a trick, right? So this is kind of a thinking question, but we kind of give it to you and show you, explain it to you. So now I want you to practice your distributive. So from yesterday. So root 3 times 2 root 3 is whole number times whole number. 2, yep. What's root 3 times root 3? 3. Are we okay with going a bit faster on that? Root 3 times root 3 is 9, so 3. Then root 3 times 5?